This presentation is on lac operons. An operon is a unit of DNA that has a cluster of genes. These genes are all controlled by the same promoter. Lac operons control the metabolic functions of cells that break down lactose or to break down lactose. So they allow for the metabolism of lactose to occur. They allow for bacteria to use lactose as a source of energy. Glucose is actually more efficient to use for energy use than lactose is, so bacteria do prefer to use glucose. However, they will use lactose if glucose is unavailable. Lac operons are inducible, which means that they're usually turned off and they need to be turned on. Lactose is the inducer, and it turns the operons on. The lac I is not a part of the operon, but it works on it. It makes a protein that binds to the operator region of the operon. It's a repressor protein, and it prevents the operon from being transcribed. When lactose is not present, the lac repressor is bound to the operator and it stops transcription from happening. When lactose is present, though, the lac repressor unbinds and it allows for transcription to happen. This basically just means that lactose is necessary for the lac operon to do its work. The catabolite activator protein is called CAP, and it's binded to the DNA in front of the lac operon promoter. It aids the RNA polymerase with attaching so it can go ahead with the transcription. CAP has to be active for the process to work, but it's not always active. CAP is only active when glucose levels are low. This means that the lac operon can only be transcribed when glucose levels are low. And this is because the bacteria wants to make sure that the lac operons are only metabolizing lactose after it's sure that all of the glucose has been used up. So when the glucose is used up, the CAP is activated, and then the lac operons get to work on the lactose. And this is again because glucose is more efficient to use than lactose is. This means that in conclusion, the lac operon will be turned on when the lactose is available and when glucose is unavailable. So lactose has to be available because the repressor proteins are unbound when lactose is available, and the glucose has to be unavailable so that the CAP can be activated. And then I drew a quick chart to show this, and it pretty much just shows that the lac operon is turned on when there's high levels of lactose and low levels of glucose. And then the operon is turned off anytime there's low levels of lactose or high levels of glucose. So this is pretty much the only time that the lac operon is on and lactose is metabolized.